So 24 is like the same problem as last time. So we're gonna use the same information. They never said it was random, so we need to be careful. We need to assume that they're random. Assume random samples, and we have to assume that they're also independent of each other. Is there statistical evidence to support the claim that juniors prefer online homework more than seniors? So we need to say out what the parameter is. So same thing as before. P1 equals this. P2 equals that. So 1 is juniors, 2 is seniors. But P1 minus P2 equals the true difference in proportions of juniors and seniors preferring online homework. The name of the procedure is a two-proportion t-test. The first condition is randomization. Randomization, not stated, but we'll assume they're random. Right. Number 2, independence. You have to check independence for both samples like before. You need to make sure that $150 is less than 10% of all juniors, and $140 is less than 8 to 10% of all seniors. Third condition, we need to check for normality. Because it's a two-prop t-test, we need to make sure that we find P hat C. And P hat C is just x1 plus x2 over n1 plus n2. So x is the number of juniors who prefer online homework, so that's 90, plus 70 seniors who prefer online homework divided by the sample size, 150 plus 140. So remember, P hat 1 is 90 out of 150. That's always x1 over n1. And P hat 2 is 70 out of 140, which is x2 over n2. And if we do out the work, this should be 160 out of 290, which is 0.552. So for the conditions, you should check it out. For juniors, it should be 150 times 0.552. That's bigger than 10. Because this is, if you have a calculator, this should be like 82.8. That's bigger than 10. And then the complement of that would be 150 times 0.448. That's 67.2, which is bigger than 10. And you check that for the seniors as well. So for seniors, it's going to be 140 times 0.552. That's going to be 77.3. That's bigger than 10. And then for seniors, and then it's going to be 140 times 0.448. That's equal to what, 62.7. That's also bigger than 10. It's bigger than 10. It's also bigger than 10. Alright, so for the work, we need to find the z-score. So the easy thing to do is just use your calculator and do a 2-prop z-test. But we'll do it the good old-fashioned way. So the formula is z equals p hat 1 minus p hat 2 minus p1 minus p2 all over square root of p hat c times 1 minus p hat c times 1 over n1 plus 1 over n2. So the z-score should be something like 0.6 minus 0.5 minus 0 all over square root 0.552 times 1 minus 0.552 times 1 over 150 plus 1 over 140. And if you do that properly, I use my calculator, I got like 1.71. 1.71. Now, our hypothesis, sorry, I never say what my hypothesis was, which is really bad of me, but H naught, so let's go back here. H naught is P is equal to 0. Sorry, not P. H naught is P1 minus P2 is equal to 0, of course. And HA is that juniors is less than seniors. And, right? No, juniors are more, my bad. P1 minus P2 is greater than 0. So, even though it's 1.71, the p-value is 1 minus the probability that the z-score is less than or equal to 1.71. So we need to figure out where 1.71 is. 1.71 on table A. 1.71 is 0.9564. 9564. 1 minus 0.9564. Now, pro tip, if you look at the negative version, the negative z-score 1.71, it's 0.0436. So 0.0436, 0.0436. That is our p-value. So our z-score is 1.71. Our p-value is 0.0436. Here, since our p-value is kind of small, since our p-value of 0.0436 is less than 0.05, we reject HO. We reject the null hypothesis. Right? We're like, no, forget you. We have convincing evidence that is greater. Convincing evidence that juniors have a higher proportion, that juniors have a higher proportion of preferring online homework. So what kind of error would you commit if your decision is wrong? Okay, so because we rejected HO, if we reject HO when it's actually true, we commit a type 1 error. If we reject HO if it's true, then we'll commit a type 1 error. The reason why this is the case is because that's the definition of a type 1.